Hello, this is our review of problems involving the segment addition postulate. And as we stated before, tomorrow we will be having a test over this. So make sure that you're really watching the video, do your own sketches so that you can practice working out the problems. And during the video, it may pause and ask you questions. So if you need to go back and look at the sketch, pause the video, use your video controls to go back and look at the sketch, and then continue and answer the questions. Or better yet, if you're drawing your own sketches, you don't have to go back, but you can pause and look at your sketch, work out the problem, and then proceed on to answer the questions. Let's look at question number 1. It says K is between J and L, which is shown in the diagram, and it says to use the segment addition postulate to determine JL. So what it's asking for is for us to figure out the length of the entire line segment. Now it's given us two important pieces. It's given us line segment JK, which is 3, and it's given us line segment KL, which is 7. And if we remember the segment addition postulate, which was the part plus part equals total, as the hint is given on the screen, you can add the two pieces together and that will give you your total. So the first part, JK, which is 3, plus the second part, KL, which is 7, equals the total, which is 10. So that I know that line segment JL equals 10. Let's look at problem number 2. It says N is between M and O, as shown in the diagram, and it says use the segment addition postulate to determine the length of the whole line segment MO. So I'm going to pause and give you a few minutes to try to do this one on your own and answer the question. Now that you've had a little bit of time to try to do it on your own, let's check your answers. Once again, it's given us some information. It's told us that line segment MN, the first little part, is 6.2, and line segment NO, the second part, is 10.6. So once again, using our line segment addition postulate, we can add those two pieces together, those two parts, to get the total for MO, line segment MO. So I've got the first part, 6.2, plus the second part, 10.6, equals my total, which would be 16.8. So now I know that MO, the whole length of that line segment, is 16.8. Let's look at question number 3. It says K is between J and L, as shown as the diagram, and it's showing us that KL, line segment KL, is equal to 6, but this time instead of giving us the other part, the other smaller line segment JK, it's telling us that the whole line segment J to L is equal to 10, and it actually wants us to figure out what does line segment JK equal. So this one's a little bit different because instead of giving us the two parts, it's giving us the total and one part, and we have to figure out the other part. So I'm going to give you a little bit of time to see if you can't figure that out and what you come up with, and then we will check your answers. Now that you've had a little bit of time to sort of figure this out on your own, or hopefully to at least give it an attempt, let's check your answers. And once again, we're going to be going back to the line segment addition postulate, which says part plus part equals total. And we're going to realize that we do have those pieces, or at least some of them. You would take the first part, which would be JK, and you would add it to the second part, which is the KL, which is 6. And then that would give you the total, which they're already showing us down below is 10. So what I have to figure out is, what do I add to 6 to give me 10? Because here's the part plus part equals total. Well, and it's 4 plus 6 equals 10. So now I know that JK is equal to 4. The other way that you could do this is realize you can undo addition through subtraction. Since they give us the total, I could take the total and subtract the part that it gives me, and then that will give me the leftover part that I was looking for. So you can also do it that way. Either way works. Let's look at the next one. This is number 4, and we're going to do this one together since this one now is involving variables and unknowns. It says n is between m and o in the diagram as shown, and it's telling us, I'm going to highlight these different pieces, that line segment mn, what it actually equals, m to n, is 3x. So we really don't know it, but we know it's the expression 3x. And then it's telling us that the next part, line segment NO, what N to O equals, is actually 4. And then it's showing us that the whole line segment MO, all the way from M to O, is equal to 2x plus 6. And it says to use the segment addition postulate to write an equation and solve for x using the part plus part equals total from the line segment addition postulate. So if I can just think about how that would work, basically what we have on the screen is we have our pieces here, because if I take the yellow, oops, let me get the right color. If I take the yellow and then I add the blue, that should give me the whole thing, which was the purple. And realize what each of those pieces are. The yellow is the MN, the blue is the NO, and the purple is the whole thing M to O. So all I've got to do is fill in those pieces, and some people just like to put like a plus right there on that dot so that you know which are the two parts, because then you can see them right together. So MN is 3x plus NO is 4, and then my total, the MO, is, in the purple, 2x plus 6. So that's the equation that I have, and now I need to solve it. So I'm going to write it over here, and then I'm going to work at solving it so that I can figure out what x equals. Now if I draw my line to show my two parts, I notice that I've got variables on both sides. I don't have parentheses, so I don't need to distribute. And if I use my scribble technique that we have seen before, where I scribble over this, if I look at the left side, 3x plus 4, I can't put those together because they're not like terms, so there's no combining here. If I move my scribble and look at the other side, 2x plus 6, they're also not like terms because like terms have to have the same letters on both of the numbers. So if it was 2x and 6x, I could put it together, but since they don't both have x's, I can't. So no like terms on either side, which means no putting them together. But I notice I have x's on both sides, so I need to get my x's together. So we always look at the side with fewer x's. Between 3x and 2x, it's the 2 x that's got fewer, so that's the one that I'm going to move. I'm going to move it over to the 3x side so that I can get them together. And we're going to remember when we're isolating that we use opposites. That's a positive 2x, so the opposite of that is a negative. And we're going to do it to both sides. And 2x minus 2x cancels, so it goes away. And then I'm just going to do 3x minus 2x, which is 1x. And then I didn't do anything with the 4, so bring it down. And I didn't do anything with the 6, so bring it down. But I still need to get this x by itself. Now I know it has a 1 with it, but technically speaking, you don't have to write that 1. You could just write it like this. So really it's the 4 that needs to move away. And once again, you want to use opposites. And since the 4 is connected with a plus sign, we're going to use the opposite of that. And the opposite of plus is minus. And we're going to do it to both sides. Because what you do to one side, you need to do to the other. And then I'm just going to notice that a positive 4 minus 4 cancels. And then I'm going to do 6 minus 4, and that's a 2. And I'm going to bring down my x. So now I've solved it, and I've got x equals 2. But where we can actually use this is we can go back to the original diagram and notice that 3x really means 3 times x, and now I know x is 2, so I can place that in there. I've got 3 times 2 is 6. So now I really know that this was equal to a 6. I already know that this was a 4 on the bottom, so what that tells me is that 6 plus 4 equals 10. So the whole thing should equal 10. Now let's see if that's what we get for the bottom piece with the 2x plus 6. So I know that that means 2 times x, and I know that x is 2, so I'm going to replace it, plus 6. And I know that 2 times 2 is 4, and 4 plus 6, yes, it does equal 10, so I get 10 for the bottom. So I'm getting 10 in both cases, so that means that my answer of x equals 2 is the correct answer because I plugged it in and I proved that either way I got 10 going across the top when I add the two pieces together, or I got 10 using the bottom expression when I just plugged it in and worked it out. So let's look at our last example. It says Q is between P and R as shown. And once again, we're going to highlight a little bit. It says P to Q, line segment is 4x, and line segment Q to R is 10. And it tells us that the whole thing, line segment PR, from P to R, is 6x plus 6. And it wants us to once again use the segment addition postulate to write an equation and solve for x. So I'm going to give y'all some time to try to work that out on your own using the part plus part equals total, write the equation, and then solve it for x. Now that y'all have had a little bit of an opportunity to try it on your own, let's check your answers. And just like before, I'm going to model this with colors. If I remember that my first part was yellow, and then I'm going to be adding it to my second part, which is highlighted in blue. And then together, that's going to equal the total, the full line segment, which is highlighted in purple. Excuse me, which is highlighted in purple. Well, let me get that off of there and get my purple good. There we go. And now I'm also going to fill in what those line segments are. The yellow line segment is PQ, the blue line segment is QR, and the purple is the whole thing from P to R. And then if I just add those pieces together and write them out, I've got my equation. So my PQ part is 4x, my QR part is 10, and then the whole thing, the total, is 6x plus 6. So there's my equation, which I'm going to write down. And now I'm going to solve it. And like before, I don't have to distribute. I can't combine because I don't have x's across all the numbers. But I need to put my 4x together with my 6x. And I'm going to go to the 4x because it's smaller. We move the smaller x, or it's fewer. And 4 is positive, so I'm going to use a negative. And we're going to do it on both sides. And 4 minus 4x cancels. 4x minus 4x cancels. So then on the other side, I've got 6x minus 4x, which is 2x. Bring down the plus 6. Bring down the 10. Okay, now I have to get this x by itself, and I notice that there's a 2 and a 6 with it. So really, I have to get both of those away. But when you isolate, the thing that you move first is a thing connected with a plus sign or a minus sign, in this case a plus sign, and it's the 6. So I'm going to move the 6, and the opposite of plus is a minus. I'm going to do minus 6 on both sides. And then 6 minus 6 cancels. So I'm going to do the other side. 10 minus 6 is 4. And then I just bring my 2x down. Now I've got to get rid of the 2, and I notice there's nothing in between the 2 and the x connecting them in between here. It's just a 2 right next to an x. So that means that's a multiply dot. So I'm going to put that multiply dot there. And then I'm going to do the opposite. The opposite of multiplication is division. So I'm going to divide both sides by that 2 to get the 2 away. And 2 divided by 2 is 1, which you can write 1x, or you don't have to, you can just write x. And then 4 divided by 2 is 2. So now I know that x equals 2.